This lecture is going to start introducing you to the SAS language. Before we get into this lecture, though, it is absolutely critical that you've watched the other videos, that you've been able to run some of these SAS programs that I suggested you use earlier. It's probably really important that you watch my solutions as well, because maybe you got it to work, but maybe not in the most efficient way, and my solution might point you towards a more efficient approach. I would also strongly recommend that you not do these things only once, but multiple times. So there's great benefit to repetition. You know, when you repeat something, when you do it multiple times, it really starts to stick, and you start to understand why you're doing all the individual pieces when you do it multiple times. So make sure you've done this before watching the rest of this video. So let's move on now, and we're going to start talking about the SAS programming language. So a few words about programming languages before we begin. Think of a program as something like a recipe. So if you wanted to make a cake and you saw a cookbook, you'd open it up and it would give you some step-by-step instructions. So it would say, take out a cup of flour and break an egg, and put in a teaspoon of salt, and then you mix it a certain way, and you preheat your oven, you pour it into the pan after it's been greased, and you bake it for whatever. All right, so what that recipe does is it spells out all the steps that you have to go through to make this cake. In the same way, a program tells SAS or whatever programming language you're using what you want it to do for you. So you're going to lay out a step-by-step recipe for doing some analysis, which might also include reading in some data first. So there's advantages and disadvantages to this programming language approach as opposed to the point-and-click approach that you've been doing so far in both SPSS and Excel. So the advantage of the point-and-click approach, where you have a menu and you click on something, is that you can, it's very intuitive. You get to see the result immediately. The problem with it is, once you've done it, you really don't have a very good record of what you've done. And if you have to do it again, that means you have to repeat all the clicks again. So those weaknesses of the point-and-click approach are the strengths of the programming approach, in that with the program you have a record of exactly what you did. If you need to do it again, you simply rerun the program, and everything is fine. The problem with programming is that students find it a whole lot more difficult than just pointing and clicking. Okay, so SAS is primarily a programming language. There are some interfaces that allow you to do pointing and clicking, but to be honest with you, if you want to point and click, use SPSS. I think you're really missing out on the power of SAS if all you're using it for is pointing and clicking. Okay, there are, broadly speaking, 4 types of commands in SAS. So the first programming certification book that we have, the SAS Certification Prep Guide for Base Programming, is going to really cover the first 2 of these. The advanced programming will cover the second 2, so SQL and macros. So what are these commands, statements, commands, whatever you want to call them? Well, the first is called the data step, or data statement. And what you do in a data statement is one of 2 things, really. You're going to either create a new SAS data set, so you get a text file from some client. You got to get that into SAS. Up until now, we've been giving you, SPSS ready-made data sets. In real life, you tend to get some sort of text file that has to be read into SPSS or SAS. You're going to use the data step to do that. Another thing that you're going to do with the data step is to modify some existing data set. So if you think about in SPSS, sometimes we had to do recodes, or we had to do a transform compute to compute a logarithm. Well, in SAS, you do those sorts of things in a data statement. So you either get data in or you modify it. Just another application that I didn't list here is if you want to do some merging of data sets. So in SPSS and in Frank's class, you undoubtedly had to do some one-to-one merges. Well, we're going to do those merges in a data statement in SAS. The next class of statement or command is what is called a proc. So what procs do is something to a data set. So now there's many examples. You've already seen some of these in the examples that you've run. So proc contents will just tell you what's in the data set. It's kind of like that variable view in SPSS. It just gives you a summary of the variables that are in there, what types they are, whether they're numeric or character, and so forth. Another example of a proc is Proc Print. What that does is it prints out some or all of a data set to the listing. There's all sorts of procs that do statistical things to the data set. So you've already seen proc means. That's kind of like descriptives in SPSS. It computes means, standard deviations, mins, maxes, skewnesses, whatever you want. You've already seen proc freq, which gives you frequency distributions. We're going to be meeting some other procs later on. Univariate's kind of like descriptives explore in SPSS. Core does correlations. There's also a ton of procs that do models. So reg does regression, factor does factor analysis, fastclust does k-means clustering, and so forth. So we'll get to those later on. All right, so these two things will make up the first 5 or 6 weeks of this class, and they are all covered in the base programming guide. The last two are in the advanced programming guide, and we'll spend the last 4 to 5 weeks on those. So Proc SQL is a full-blown implementation of the structured query language. Structured query language is an industry standard language for interacting with relational databases, such as Oracle, MySQL. There's an SQL engine sitting underneath Access. So it's just this industry standard language. SAS happens to implement this language, and it's very good if you have multiple tables whenever you have a relational database. So it's very important to know that. We'll also talk about macros. Macros will automate commands for us, and again, we'll get to that later. Now, the most commonly made syntax error in SAS is forgetting the semicolon. So if you have an error message, I'm going to guess that there's about a 50% chance that the reason for that error message was you forgot your semicolon. So always remember that all commands in SAS are ended by a semicolon. If you've been studying the syntax window that's generated by SPSS, SPSS also is a programming language. It's not used. You don't have to use it because the point-and-click interface is better on SPSS. But in SPSS, everything ends in a period. So if you wanted to do a character for character translation from SAS to SPSS, change all semicolons to periods. Now let's move on to the lib name statement. You've seen examples of this already. Students find lib names and libraries kind of confusing, and they are. So in SPSS, if you use the programming language, you can reference something by specifying the path to that file. In SAS, you can't do that. It's more complicated. So everything in SAS is done through libraries. So what is a library? Well, a library on a PC or on a Linux workstation is just some folder on the disk. Now, to get at that folder, you have to assign a SAS libname pointing to it. So You've seen some examples of this already in your code when you saw something like this, SAS libname, SSCC, and then here's a folder. The way to think about this is that you're associating this name, SSCC, with this location, this folder on the hard drive. So whenever SAS sees SSCC, it means, well, go look in this folder. So we've run this command a couple times. When you say proc contents data equals sscc.employee, what this tells SAS to do is go look in whatever SSCC is for the employee data set. Now, this SSCC, as I indicate up here, can be any valid SAS name. So valid SAS names begin with letters. They can have numbers in it, can't put spaces, cannot put commas in them. In general, you're going to keep these things fairly short, like 8 or fewer characters. It had to be less than 8 characters. And now I think you can get it. Now they can be a little bit longer than that. But in general, you keep it pretty short. All right. So it doesn't matter what you call this as long as you are consistent. So I'm going to jump over for a second to my Unix window, and let's go back to the Siegel data set. So let's VI that thing. And so this is essentially where we had that SSCC code that I pulled from here. Now what I just said was it doesn't matter what you call it as long as you're consistent. So if I wanted to call this something other than SSCC, I could do that. So for example, instead of SSCC, I'm going to call it IMC 498. So I'll position the cursor over SSCC to a change word, CW, IMC 498. I've just changed the name of my libname. Now, if I were to run this at this point, SAS would get very confused because it's now never heard of SSCC because I haven't defined it up here. So if I want this program to run, I need to change all of these instances to, oops, wrong one. Let's hit next. Change word IMC 498. We'll hit next, period. Next, period. Now this will run, and we'll get exactly the same output as before because the libname itself is completely arbitrary as long as you're consistent. So just to convince you of that, let's run that. And you'll see that SAS is completely happy. No errors were found. And you'll see that it has assigned IMC 4098, here we go, to that location, and everything ran, and you get exactly the same output as you had before. Okay, so that's a libname. One more thing. There is a special library that SAS creates for you. It's a library called work. Now, work is what I call a temporary library. And it's temporary in that it gets deleted whenever SAS closes. Now, when you're running batch mode, as soon as the program ends, SAS closes. So this is kind of for like a scratch space. You can have your scratch paper, if you will, in this work library. Now you've already run this program where you said, data my data. This thing read in some data. We're going to get a lot more on how you read on data shortly. But the thing to note about this is that I stuck it in work. So my data, I didn't put a libname in front. So if you do not put a libname in front, SAS assumes that you want to put this in the scratch folder, work. Now, I could have said work.mydata, and SAS would do exactly the same thing. When I printed it, I think I printed it earlier, data equals my data. If you say data equals work.mydata, you will get exactly the same thing because my data and work.mydata refer to exactly the same file. So that's about it for libnames. The only other Yeah, the only other folder that you may want to know about is the current folder. So if you want to create a data set of your own, you can define a library for that. So let's go back, and I'm going to re-edit Tiny. So remember we made Tiny. Tiny is what read in that my data. Now let's say that I wanted to keep this this data set, my data, but I want to stick it in my folder. So here's what we're going to do. We're going to say libname. My favorite name for the current directory is cur. You can call it whatever you like, but whenever you see cur in one of my programs, it means the current directory. The name for the current directory in Unix is dot. Don't you love that? So libname cur dot means put this in the current directory, the working directory, which in this case is going to be class, since we're sitting in that folder. Now, every occurrence of my data, I want to replace with cur.mydata. So let's do that. I'm going to search for my data. So I do /mydata, and now I'm going to do an insert, cur dot. Now I'm going to hit next, next, dot. Next, next, dot, next, next, dot, next, next, dot. Let's go run this. So I'm going to do a sass on Tiny, and let's edit it. You'll see that there are no errors. Cool. If I hit :n, we get the output that we had before. And here's the sass program. I'm going to get out of this by hitting :q. Let's do an ls now. What you will see when you do an ls is that there is now a file located in my class directory called mydata.sass. That is the SAS data set that I just created. If you do an ls-l, remember ls-l gives you details, what you will see is that it was created, and today's March 1st at 12:02 p.m. And so you'll see that I just created this thing. All right, so my point with this is I've created a new a data set in my folder as opposed to this shared SSCC thing. That's good enough for libraries. A few more things. We've already talked about proc contents. I said it's kind of like the variable view in SPSS. SAS data sets are organized in a certain way. So the first part of that data set is a header that contains information about the data set. What contents does is it just displays what's in that header information. So it gives some basic summary information, like what's the name of it, how many observations are there, how many variables are there any indices? Well, there aren't. We'll talk about indices in the last week or two of class. Tells us whether it's compressed, whether it's sorted. Gives some information about where that file is located physically on the disk, so sscc.data, data sets, all that. And then it gives us all the variables. So there are 4 data variables. It gives us the types. So 3 of them are numeric, 1 is character. Tells us something about the length. So that character variable is 7 characters long, whereas the amount variable is only 4 bytes long. Tells us something about how to print it. So we're going to print the gift dates as a date 9. More on that in the next video. And gives us some meaningful labels, which are very similar to the SPSS labels. All right, so that's what contents does. You've already seen several of these. The next topic that I want to cover from the base programming guide is system options. So system options will tell SAS how to display information or how you want to read stuff in. Let's just talk about displaying information today. We'll talk about some other ones later. Here are some commonly used options. So one thing you might want to do is change the width of the the output line. So if you say line size equals 100, what that means is you just want 100 characters across. You can abbreviate it to LS, and that's what I always do. You can set the page size to some number like 1,000. So if you say PS equals 1,000, that means you're going to have 1,000 lines of output before you get another header line. Sometimes you don't want the date to print, so you can suppress that with no date. If you want to turn dates back on, you say date. These, by default, SAS displays dates. No number turns numbers off, and so forth. So you can stick these just about anywhere in your SAS program. I usually put them towards the top. So here is a valid SAS program. This is what I would recommend doing. You know, get your lib names out of the way, then give your options. Doesn't really matter if you put options first or lib names first. So here I've set the line size to 72 and the page size to 100, turned off dates. Okay. There are more options discussed in Chapter 2 of the base programming book or Section 1.14 of the Little SAS book. Another thing that you might want to do to make your output a little bit more readable, document things a little bit better, is to add some headers and footers. So you create headers and footers with the title and the footnote command. So let's take a look at my program. In here, what I had before, had set some options, but then title, this is the data set from Siegel. That title will appear at the top of every page of output. Then title 2 will appear immediately below. It's kind of like the subheading, employees from some company. And then the footnote is going to appear at the bottom of every page. So this analysis was done by me. I encourage you to type this in, nothing like getting good practice, and see what the output looks like. Maybe try modifying the title, and you could add another title if you want. Okay, so give that a try, maybe mess around with the options a little bit, get to know them, and then in the next video we will talk about Proc Print.